All right, our last problem is going to be quite an involved problem. I mean, we're going to throw a lot of given stuff at you. We got congruent triangles in here, which we can use CPCTC on. So what I'm asking you is I want to know what the interior angles of triangle HEC are. So this triangle that I'm going to kind of highlight right here, even though I did a bad job of drawing this triangle out for you. So this triangle right here that I'm highlighting, I want to know what each of its angles inside, what their measures are. Okay, so this triangle that's right here, I want to know that angle, I want to know that angle, I want to know this little sliver of an angle that's right in there. And I've given you some helpful guiding angles to help you through this. I mean, we're going to want to find the measure of angle 1, measure of angle 2, measure of angle 3, and the measure of angle 4 to help us find what the measure of angle HEC is. So that's my top angle up here. Measure of angle EHC. It's my angle that's right here. Oh, my top angle HEC is right here, EHC right there, and then ECH right down here, that little sliver. So if we can find these guys, we can do everything else. So let's put in some information that we know. Well, actually, before we do that, why don't you go ahead and try this. Put in some of this information that you know. See what you can come up with. Remember, this is all about interior angles of triangles and using some of the stuff that we know, especially congruent triangles with CPCTC. Go ahead and try this problem real quick. Okay, so segment GC, that's right here, and AC, bottom one, they are perpendicular to each other. So there's that symbol. AB and segment BC are also perpendicular to each other. So there's that guy. We also know that segment AB is parallel to segment DE. So we know those are parallel. We also know that DEC, this guy right here, I'm kind of highlighting right there. We know that it is isosceles. Okay. And then we also know that my two triangles that had the perpendicular in them, this guy right here, this large triangle, and this large triangle right there, they are congruent. So we can use some of that CPCTC to help us out. And then finally, we know that this angle right here has to be 50 degrees, and that's where we're going to start from. So a couple things we know. This triangle right here, triangle ABC, ABC, this first right triangle right here. A couple of things we already know about it. We know measure of angle 4, since it's perpendicular right there, has to be 90 degrees. The other thing is that these angles inside this triangle ABC, we know this is 90, we know this is 50. We can easily figure out measure of angle 3 because we know all those angles have to add up to 180 degrees. So if we add those two together, that gives me 140 degrees plus the measure of angle 3 equals 180 degrees. So measure of angle 3 must be 40 degrees when you subtract 140 from both sides. Alright, because these lines are parallel, we have a relationship established between 50 and angle 1. These angles, you kind of seen this before when I did my mountain picture with my triangles. These are the two angles that are in question. Well, what are they? They are corresponding angles, and corresponding angles are always congruent. Okay? So those angles are always congruent. So angle 1 has to be 50 degrees. And then another piece, since this is an isosceles triangle, oh, excuse me, before I get to that, number 2, we also know angle 2 is 50 degrees. Let me tell you why I know angle 2 is 50 degrees. This triangle right here, triangle ABC, is congruent to triangle FCG. FCG. So since I'm looking at angle A, who matches up with angle A? That would be angle F. So there's that kind of angle F within that triangle that you see. So because of CPCTC, I know these two angles have to be congruent. So that's a lot of information for us that we now know. We know that's 50 degrees. We know that's 90 degrees. We know that's 50 degrees. We know this guy right here, measure of angle 3, that's 40 degrees. And so there's kind of everybody that we know right around in here. So now we're going to start working on this triangle that we want to attack. Well, in order to do that, we know this larger triangle, DEC, that I highlighted, we know it's isosceles. And because it's isosceles, we know that these base angles have to be congruent. So angle D and this guy right here, angle ECD, have to be congruent to each other. They're base angles. They're across from my congruent sides. Okay? So since this angle is 50 degrees, whatever this angle is plus measure of angle 3, which is 40 degrees, has to be 50. So since 40 degrees plus whatever my missing angle is has to be 50 degrees because it has to be congruent to this guy that's over here because of that base angles converse, or base angles theorem. We know that my missing angle, or angle ECH, has to be 10 degrees. So ECH we know is 10 degrees. Alright, so we're starting to attack this problem. We know that that's 10 degrees right there. Okay, now we also have this little triangle in here, DHC, this guy right in here. Well, we know parts of it, so I'm going to kind of pull it out. I'll let you see it real quick. Okay, and actually that one triangle we're talking about, our isosceles triangle, kind of looked like this. This was my isosceles triangle, and we knew that base angles were congruent. So this was 50 degrees, so that meant that this whole angle right here had to be 50 degrees. And we already knew that part of it was 40. That's how I got the 10 that we were talking about down here. Because 40 plus whatever this is had to give me 50. So, but this is my triangle DHC. Okay, well actually part of C. Okay. We know that this is 40 degrees. It's right there. We know that this guy's 50 degrees. We can now figure that guy out because that's just our triangle sum theorem. 50 degrees plus 40 degrees plus whatever that guy is up there has to be 180 degrees, right? So that's 90 degrees plus whatever that is equals 180 degrees. Well, lo and behold, this angle that's right there has to be 90 degrees. Okay? So now we can get the rest of our stuff, because if you look at this, well, if this is 90 degrees and then my two opposite angles have to add up to that, okay, these two angles have to add up to 90 because of my exterior angle theorem. Well, that means that 10 plus whatever my top angle is has to be 90. That means that my missing angle that's at the top, angle HEC, has to be 80 degrees. And then now it's pretty easy to figure out this other guy. All you got to do is just add all three of these angles up, and that should equal 180. Or another way to look at it is there is a relationship between these two angles. These are a linear pair. Linear pair right there. Or you can use your triangle sum theorem. Lots of different ways. See, the more that we know in geometry, the more that we can pull off. But if I just take 80 degrees plus 10 degrees plus whatever my missing angle is, because it is a triangle, they all have to add up to 180 degrees. That's 90 degrees plus whatever that guy is equals 180 degrees. So my missing angle, 90 degrees. And there they all are, using a lot of different ideas like isosceles triangles, parallel lines, perpendicular, CPCTC. So a lot of cool stuff that we can do with that.